Hi, welcome to Physics A-Level at JCG. We asked some of our current physics students in the A-Level what they thought about physics, and they said, came up with a few ideas, including some of this. They said physics is extremely interesting, challenging, and great fun. And I agree with all of those, and I hope you will too if you decide that physics is also for you. It can lead to a huge number of really interesting, valuable careers, including civil engineering. Former head girl Rachel Hayden went off and studied, has become a civil engineer after studying at university. Can lead to a career in astronomy and the space industry. And we do have a number of students going off, including somebody from this year, keen on taking astronomy and astrophysics at university. We have some people studying mechanical engineering, either in the race industry, automotive, but also we've had former students, Amna Hassan, who's now Amna Khosrow, working for international firms such as Jaguar Land Rover. And then she worked for a while for Arrival, which was an up-and-coming electric vehicle manufacturer, and she's been back in touch with JCG and given some workshops to students lower down the school. A-level in physics can lead to a degree in medicine and a really valuable and interesting career in that route. Or alternatively, you could go down the finance route. People are crying out for physicists in the finance industry. That logical thinking and problem solving really gives you a fantastic basis if you decide that you'd like to go and make your millions in the finance industry. Can lead to an interesting career in electronic engineering. Mr. Aguiar himself did some work with a lot of electronics and aeronautical engineering, and prior to working at JCG, he worked at the airport and supported them with their electronic engineering up there. Could also lead to a career in software engineering. If you're interested in IT, a physics A-level will certainly support a degree or further work in that industry. And perhaps you are interested in finding out how physics can develop understanding of the world and the universe. If so, perhaps physics research is for you. We're looking to try and solve this climate problem and to reduce our carbon emissions. So perhaps you might be interested in working in the nuclear industry. And we do have students going off working a whole range of energy fields, including how we can get our energy in a more environmentally clean way, and people go off and study environmental science. We think that you should study physics A-level because physicists earn more cash. According to a 2005 PricewaterhouseCoopers report, a graduate in physics or chemistry earns around £180,000 more during their career than someone with A-levels but no degree. And I'm sure in many years that pass since that report was out, those numbers are going to be even higher. And we've found that a report by Professor Geraint Jones from the University of Lancaster Management School found that the highest salaries are employed by those who took physics, chemistry and biology together at A-level. In our physics A-level, we look at the very big, we look at the huge universe scale of things, and we also look at the very small. We look at atoms, we look at what makes up atoms, we look at the nucleus, we have a look at the protons and what makes up protons, which some of you might know are quarks and some subatomic particles. We try and keep an eye on science in the news, and recently we've been really interested in the James Webb Space Telescope, and we've been looking at how this incredible feat of human engineering is going to be opening up our world and how we're going to get a better understanding of what our universe is like. I'm a huge fan of Jocelyn Bell Burnell. In 2018, she won the Special Breakthrough Prize in Fundamental Physics and was awarded £2.3 million prize money, which she donated, or she's asked for the Institute of Physics to support women, minorities, and refugees to become physics researchers. She visited JCG a few years ago and spoke to her students, and she told us how she was in a very small minority studying physics in a class full of men, and this is something she feels passionate about, that she wants women to go on to study physics in particular, about all STEM subjects, and she's a huge fan of supporting people to go and fulfill their potential. The Institute of Physics has come up with a video based on the prize money that Dame Jocelyn Bell Burnell won, and we're going to have a quick look at this video now. Although it does focus on the fact that anybody can do physics, I'm particularly inspired by the solutions that young people such as yourself are going to find to the problems of the world's challenges, and how A-level physics can help you achieve that. Let's have a look at this video now.
What does a typical physicist look like?
Most people who I know who do physics are boys.
I think physicists tend to be rich white people.
To pursue physics, you have to come from a wealthy background.
I don't feel comfortable doing physics.
I think there's not a lot of girls in the STEM sector.
Over to you to solve these problems.
I guess if you like physics, then nothing should stop you.
Someone's always going to tell you no. As long as you think you can do it, then you should go for it.
Physics is for everyone. It doesn't matter how much money you have or where you come from.
People go into it thinking it's a lot more complex than it really is.
It's not based on history, it's you.
Just because I'm interested in physics doesn't mean I have to go to uni. I can do an apprenticeship as well.
Both my physics teachers are girls, so it's really inspiring.
Physicists are just regular people.
Physicists could have silver nail polish.
Anyone can be a physicist. It doesn't matter who you are, what you look like.
If you feel like you can do it, then do it.
The future of physics is equal.
And I think that really captured some of the problems, the challenges the world faces, and maybe starts to get you thinking about what we can do to try and improve our world. I think A-level physics really helps develop you in a number of areas, including these transferable skills. It advances your talent for teamwork. It improves your organisation. It helps you to develop your ability to understand new concepts, and it certainly hones your aptitude for maths and problem solving. We have a range of opportunities for those that are doing A-level physics, including local talks and visits, including seeing engineering in practice. We've got webinars and courses that we take part in and encourage our students to take part in. Recent ones have included Physics in Action, a webinar, and Robotics in Space, which is an online course. We do have an entry criteria. We do need students to take either physics or possibly double science, GCSE or IGCSE, and you need a grade 6 in that. And you'll also need to have a maths GCSE or IGCSE grade 7. We ask students to take physics A-level in addition to physics maths, in addition to maths at A-level. We found that it really has become a bit of a barrier for those students that are not taking physics and maths, and they do tend to struggle with the maths skills. So we've made that a criteria. You will need to take physics and maths at A-level. We look at the applications of physics, and we look at how they can protect people, make travelling safer, for example, through airbags. We look at how physics can be used to investigate satellites and geostationary satellites, communication satellites. I open this up a bit to the floor here at this stage and ask you to look at these medical images and see if you know any of these types of imaging. This first one, perhaps you'll be aware, this is X-rays, and this second one over here is quite a common one. It is ultrasound imaging. The bottom three are a bit harder. Maybe people have a bit of a background in medical industry. This one here is a CT or CAT scan, computerized axial tomography. So we're taking slices of the human body using many X-rays. We've got another tricky one here. This one's showing really nice soft tissue here. And this is MRI, magnetic resonance imaging. And finally, we've got this one over here, which is a PET scan, positron emission tomography. And we look at these medical imaging in detail during the course. Again, another question for those of you watching the presentation. What do these two have in common? It's a bit of an odd one, perhaps. We've got some red blood cells here, and we've got somebody taking using a speed camera to find out how fast cars are going. So actually we can use some of the processes from this speed camera and we can use something called the Doppler effect, and you can fire a wave into the blood cell, an ultrasound wave. It bounces off these platelets in the same way that the signal will bounce off a car. The signal returns to the speed camera, or the signal returns to the ultrasound transducer, and you can compare the two frequencies of the emitted and the received wave, and that difference in frequency can tell us how fast either the blood platelets are moving, or the red blood cells are moving, or how fast the car is going. So we can use the Doppler effect to find out the speed of cars and find out the speed of blood in blood vessels, which can be used for diagnostic imaging. A-level physics is split into 3 papers, paper 1, 2 and 3. First 2 are 2 hours 15 minutes. Paper 3 is 1 hour 30. They involve some multiple choice, some short answers, some long answer questions, and there's also the practical endorsement. So there are some practical investigations that take place over the course of the 2-year A-level course, and at the end of that, hopefully, so far we've had everybody achieving that practical endorsement. What do we need from you? We want an inquiring mind, a thirst for knowledge. We want a commitment and a willingness from you to try your best. We need you to do your homework every week to the best of your ability, and we want you to find out about interesting aspects of physics in your own time. And overall, we say, enjoy physics, it's fun.